So this problem is slightly different than the problem of the week, but I changed up the numbers. The steps are the same, so you can follow the steps to get your problem of the week correct. So we got two people running towards each other. Now in this case they're 6 miles apart. Takes them 30 minutes to get there, and one person is 1.125 times faster than the other person. So that means, let's say the slower person is like 7 miles per hour. We'll talk about miles per hour for a second. First person 7 miles per hour, then the faster person is 7 times 1.125. So the other person runs 7.875 miles per hour. Right? So to find out friend A's speed, because we don't know directly what friend A and friend B's speed is, to find out friend A's speed, we take 1.125 and multiply it to friend B's speed. So for this problem, you're letting x be friend B's rate, friend B's speed. Okay. I think I might be getting a little bit ahead. Just as a reminder, this is just like the stuff you do in 3.5. Okay. The equation we're working with is distance. The distance we travel equals a rate that we're traveling at times the time. And the units of the rate and time can be flexible depending on the situation. In this situation, we want miles per minute for a rate. Okay, so the units here for the rate is miles per minute. And that means, time, we could express it in terms of an hour. From 10 o'clock to 10:30, that's 0.5 hours, right? But that's actually not going to help us with the units that we're supposed to solve for. We need time to be in terms of minutes. That way, these units can cross-cancel like we saw before in the course. Okay, so we'll want to keep that in mind, that the rate is miles per minute, so we need to plug in minutes for our time variable. Oops, this is from a previous attempt at a video. Yeah, so the equation, the words that we just saw down there, I'm about to do here. We need to make an equation to represent this situation. So the distance that friend A covers, if you add that to the distance that friend B covers, that should equal 6 miles because they're meeting up in the middle, right? So here's their houses. Oh boy, that's a terrible house. Let's see if I can redeem myself. Okay, not much. Looks more like a tree. But here's their houses. If friend A is the blue line, he's a little bit faster, so he should cover more distance. And then friend B is the green line. You should add these two distances, and it should equal 6, right? Distance that friend A travels plus the distance that friend B travels, that should equal 6 miles. So we have an equation to represent distance. Okay, to make that equation happen, let me clear this if I can. The distance that friend A travels is the rate of friend A. And I'll remind you why we're using 1.125. This is the rate of friend A times the time it takes until they meet up. It takes 30 minutes until they meet up, because we said minutes is our units. And then we've got friend B is running at x for a rate times time. If you add the distance that friend A covers plus the distance that friend B covers, that should equal 6 miles because they're meeting up together. And now we have an equation to solve. Remember, we have to multiply 1.125 times friend B's speed, because friend A is a little bit faster. So like 1.125x is definitely bigger than 1x, right? And that should make sense because friend A is supposed to be running faster. Okay, so now I can solve this equation. We can multiply in whatever order we choose if there's 3 or more numbers that are multiplying to each other. So I'm going to do 1.125 times 30. And then we got 30x. That equals 6. And now you can combine like terms. We have 33.75x plus 30x. It makes 63.75x. And then we can divide both sides by 63.75. So x is going to be 6 divided by 63.75. That's 0.094. We'll round. Remember, that's friend B's minutes per mile. Sorry, miles per minute. Man, I'm sorry. That's friend B's miles per minute, like we set up above here. When you said that the rate is going to be miles per minute, that way these units cross cancel. Okay, so that's friend B, 0.094 miles per minute. And that makes sense, right? After 1 minute, you shouldn't travel a whole mile. This is a fraction of a mile that's traveled. And then friend A's speed is just going to be 1.125 times friend B's speed. So 0.106 roughly. That's friend A's minutes per mile. 0.094. Okay, so I cleared the board so we have room for part 2 here. That's minutes per mile, right? Friend A travels, man, I said it wrong again, sorry, that's miles per minute. Friend A travels 0.106 miles for 1 minute. And if we want to express things in terms of minutes per mile, like I keep saying for some reason, just flip the fraction. We can do this. This is perfectly fair to do because it's the same expression of some sort of mathematical idea. Right? If you say you type 60 words per minute, that's the same thing as saying 1 minute gets you 60 words typing. Right? If you flip those units, it still expresses the same thing. So 0.106 miles for 1 minute is the same thing as 1 minute for 0.106 miles. And so to finish that out, you can just divide that in a calculator. That gives us 9.43 minutes per mile. But the final answer, they want it in terms of miles and seconds. So 9 whole minutes, and the 0.43 is 0.43 minutes. To convert that to seconds, take the fraction of the minute and then multiply it by the number of seconds in a minute. So we got 9 minutes, 25.8 seconds, I think it was. Okay, and you just do the same thing with the other rate. It's 0.094 miles per 1 minute. That's the same thing as 1 minute per 0.094 miles. You divide that in your calculator. 1 divided by 0.094 is 10.64 minutes per mile, which is 10 minutes. And then to convert the 0.64, we're going to take 0.64 times 60 seconds in a minute. 10 minutes, 38.4 seconds. Okay, so you'll do the same thing for your problem of the week as what I did here, just with different numbers.